Welcome to the LongNoseThunder Re-Reflight? Revisiting with an old friend? And some lessons learned about cockpit decision making. Check, check, check. I can't tell you how stoked I was to have this plane come out of the woodwork. This was a project that was really important to me back when I did it, back in 2016. And I felt terrifically lucky to have the opportunity to revisit the airplane and move it to the next chapter in its life. If you haven't caught up, there are previous videos for this program on the YouTube channel. Please go back and catch up now.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
In 2016, I was a freshly hired test pilot at the Mooney R&D facility in Chino, California. I was excited to be getting access to an airport I've never really spent much time at before, the Chino airport, and I was doing what we all do, poking around in the back hangars to see what was there that was cool. I happened around a corner at Threshold Aviation there on the south side of the Chino airport. Went around a corner and happened to come across this airplane. Did some Googling and found that not only was it just as rad as it looked walking through the hangar doors, but it was for sale. So I reached out to the owner, to the broker who was working on selling the airplane, and just let him know that I was excited to help however I could. I got lucky, and the new owner, when he purchased the airplane, reached out and asked for me to help him get the airplane ready to ferry it from Chino on down the line onto the owner's place. It turned out that the airplane had never really finished its phase 1 program, and so that meant that there was an opportunity to do a fair amount of flying and some real test work on the airplane in the event that I was willing to do all the rest of the work that was required. So by the time we were done, and if you've watched the previous videos, you know, we spent a lot of time with the hydraulic system. Yeah. After hours, at Mooney, work ended at 5:30 or whatever it was, and then I had an Airbnb I was crashing at, so I had a few hours there every night, and I was more than happy to learn about Thunder Mustangs during that time. I spent a lot of time on the brakes. Spent a lot of time on the engine. Hey Jim, what are you doing?
Washing an airplane.
Ended up being a lot of hand labor, a lot of working on the airplane labor for the amount of testing that I got to do, but it was a fantastic experience. I ended up delivering the airplane to Denver, where the other test pilot, Lance's other test pilot, took over, and the airplane disappeared into the woodwork, and I didn't hear anything about it since then. Well, here we are in Denver, Colorado. This is the final stop for today's trip. On to the next one. Airplanes are cool. In the time that it was gone, the airplane passed through a couple different maintenance shops. It got a new instrument panel. The engine was overhauled, and eventually it ended up in Deland, Florida, at the home of Walter Engines. So there's a lot of things to get excited about the LongNoseThunder, one of which is the engine, right? The Walter 601 is it's a weird motor, right? And also there was a time when these engines were just becoming available from Czechoslovakia where they were really cheap and they were getting used on a lot of cool home builds. And it's not really well supported in the US. So if you're gonna play with Walters, you're gonna end up in Deland, Florida. There's only a handful of outfits that maintain the 601, and they're all in Deland. In my personal experience, when I was looking for information about the 601, I found myself coming across the same name over and over again, Cook. John and then his son Quentin are, in the little bit of research I was doing back in 2016, they are the world experts. So in the case of 2016, we hired John, Quentin's dad, to come out to Chino to fix the fuel controller on the airplane before I started flying it. He was there. I didn't get to meet him. Certainly never got to meet Quentin. And so everything that I did to learn about the Walter was done at a distance. My favorite part about this project, when Lance reached out to do it, it meant that I was going to get to go to Turbine Power Technologies and meet the Cooks, to meet Quentin, which felt like, you know, whatever was going to happen, that was going to be an opportunity that was not to be missed. Arriving at Turbine Power Technologies, it's a humble little building, just a couple little hangars on the south side of the Deland Airport Business Park. It's hard to imagine all the cool things that have come out of those hangars when you see sort of the humble outside. And when I say the stuff that's inside, it really all centers around this man, Quentin Cook. I say Cook, his name is actually much more difficult to pronounce. Luckily, he lets us call him Cook. So walking through the front door, you walk through a small office, but then very quickly you're on the shop floor with this sort of what you would expect for turbine engine maintenance going on, but with just a really small team. I saw 4 employees besides Quentin while I was there. I wouldn't be surprised if there was a couple more, but when you take that 4 people that I saw and the fact that while I was there, I saw maybe 4 or 6 engines get delivered for overhaul, and I saw 2 engines besides the engine that I took off site leave. It's a pretty good indicator of a good, healthy business and a strong Walter 601 community, which bodes well if you're interested in playing with the 601s, which I am. Like so many things, when you get to a shop like this, you start taking for granted all the access that you're having, right? I mean, there was a time 2 years ago where just taking the upper cowl off the Thunder felt like I was getting to learn all sorts of new things about the Walter. And here I was in Quentin's shop, surrounded by all the bits that add up to a 601. It gets easy to take that for granted. Walking through the shop, you could see engines in various stages of overhaul, everything from stuff that just come in that was just being disassembled, to stuff that was being assembled, to the engines that were actually on the ground running truck. When I say it's easy to take it for granted, it's easy to take it for granted because I was there for the LongNoseThunder. So the Longnose had been there for the better part of 3 years. Again, I'm paraphrasing. The airplane showed up for some sort of relatively routine engine maintenance and some modifications underneath the cowling. And then while it was there, the engine was damaged, and as a result, the engine had to be overhauled, and Quentin did that work. After it was overhauled, Lance had trouble getting out to the facility to pick up his engine, and as a result, it sat, like I said, for the better part of 3 years, which is a long time. So walking around the corner and seeing the airplane for the first time in, whatever, just 2 years, 3 years, it had been a while, I was sort of struck initially by the changes that had been made to the airplane. So obviously, time has passed, and the airplane looked fantastic. It was presented well in the hangar, but also there were changes. So the first one that's most noticeable, I mean, if you look at the old videos of the work that we did on the airplane, everybody wants to talk about the scoop. I took a lot of flack on the internet for what kind of a moron would put a GoPro camera in the scoop. Don't you know the scoop is for engine cooling? And the point was that because the Walter didn't require a radiator, which maybe that's obvious, that scoop on the bottom was there, but it wasn't doing anything. So the front of it was open, had the stock Thunder Mustang opening, but the back of it, there was no exit door. So it was just there was a screw-on panel that closed up where the exit would be behind the radiator normally. Like I said, there was a lot of comments on the internet. So if I was getting comments on the internet, I can only assume that when Lance traveled with the airplane or showed the airplane to people, that was a common question that he got. What's in the scoop? And so you can see his solution to that problem, which is he installed 2 cool air vents and a taxi light and a landing light. I had never seen it before, and it's an interesting way to use the space. I think it's probably better than just having a big dumb hole there, but cool. The other thing was the changes that had been made to the panel. Obviously, big new Garmin touchscreen and then a backup touchscreen below. And in doing that, they had to move some stuff around. The fuel gauge that had been in the airplane all along was still in the airplane, but it had been moved, and then the new VR panel had been added with all the engine's information summarized on an LCD screen rather than like it was like a D type screen before. And with this was probably some of the bigger challenges that I could see coming into the project was that I was gonna have to interface with this panel in order to move the airplane some 1,000 miles from Florida to Texas. And these were the tools I was gonna have to do that. So we get a lot of questions, and one of the questions we get a lot is, you know, can I get your inspection checklist? First of all, I consider our checklist proprietary, but it's proprietary in sort of all the wrong ways, where the reason it's proprietary is it's sort of, if you read through our checklist, you can see sort of the things that have bitten us on other programs, right? Like the reason we have to make sure we look for X is because, well, on another program, nobody did that, and maybe we didn't catch it till later than we would like to acknowledge. So when we say the checklist, really you need to be thinking about 43 and delta. It's the inspection criteria that's called out in every condition inspection on every experimental airplane out there, and it's the basis of what we're looking for. So when a customer asks, what are we doing in the inspection, I would say we're doing a condition inspection. Typically the inspection that we do takes a couple hours. I like to plan for 3 or 4. We go through the paperwork, we open up all the covers, we look at the flight controls, we obviously look at the engine, we look at the fuel system, we look at the electrical system, we look at the radios, etc. Make sure the pilot fits in the airplane, make sure that the harnesses are safe and are in a geometry that's not going to hurt the pilot if something happens. Make sure that the emergency egress systems work. It's standard stuff, but in the context of the flight test environment. While I say that that's the checklist, I think it's important to bring up what's actually going on. So yeah, we're looking for nuts and bolts and standard, lefty-loosey, righty-tighty stuff, but what we're really doing is a little bit deeper than that. So number one is it's an interview with the owner about what are the expectations of the day. Very directly, you're brought out to do a thing. You want to make sure you understand what the owner meant when they told you to do the thing, right? A lot of these cases during the inspection is the first time we're spending any face-to-face time with the owner. So it's a great chance to sort of figure out what are their expectations, what are their background, right? Am I dealing with a bush pilot who's only dealt with fixed gear airplane, ragwing construction, or am I dealing with an ex-military guy who's never flown anything this light before? And what we're really trying to do there is figure out what are the blind spots of the program, right? A lot of times, you can look at the airplane all you want, but everything you need to know is from talking to the guy that spent the most time with it. And that's typically the owner. So getting those expectations for what does he expect? What does he know about what he expects? What does he know about the risks associated with it? Does he fully understand what he's asking you to do and how that puts the airplane at risk, and then therefore all of his investment, and the inspection is a great time to do that. The last thing is going over limits and envelopes and starting to have the beginning of the conversation that would eventually end on a worst case day where you've melted an engine or crashed an airplane. A great example is CHT limits, right? So everybody knows that you can Google your Lycoming manual for your Lycoming 320, and you can come up with a number for a CHT limit. CHT limits mean different things to different people. It's not uncommon where you say to an owner, you say, oh, what's your CHT limit that you want to use? And they'll say, well, the book says 440 degrees. Now, does 440 degrees mean you never want me to get to 440? Or does 440 degrees mean if it gets to 440, but it's only on the climb and you're already pulling the throttle back, that's okay? Does that mean you want me to land immediately? Does that mean we're gonna tear the engine down? Does it mean that you're gonna be annoyed if I taxi back and I'm like, oh, well, it was 439 degrees and I didn't wanna let it get to 440, etc. And trying to establish what the bounds of those things are, right? And when I say the context of the worst conversation, which is that last conversation, where you've damaged the airplane and you have to taxi back, and they say, you have to say, well, we set this expectation. This is how I said I was going to manage, for instance, CHT. So I'm going to pull the throttle back. I'm going to make sure the mixture's full. I'm going to accelerate the airplane, whatever the deal is. And it did or didn't work. But again, a lot of this stuff is about establishing, what are the expectations, what is acceptable, so that you can effectively be the hands and eyeballs of the owner in the cockpit while they're on the ground. So first step was taking the airplane apart. So here you can see Jose. It takes a step stool to take the cowling off the LongNoseThunder, so you can see getting the ladder, take it out. They're all quarter turn cam locks, but they all fall out, so you got it's a little bit tricky to get them out and get those all out. And then we're working together to pull the upper cowling. So because of the longer, the extended nose of the LongNoseThunder, the cowling's longer, and it's a little bit hard to manage with one person. So once we get the cowling off, of course, you open the treasure chest. You want to take a look. So go in and take a look, and very quickly it's obvious that some significant work has been done here. The LongNoseThunder, when I was first introduced to it, had the same 4 battery pack setup. It's a 24 volt system, so you use 2 batteries ganged together to make 24 volts, but then it had 2 sets, and the one set was mounted there on the firewall, but the second set was underneath the engine. And in the case of when I was operating the airplane, those batteries were in a situation where they were getting really hot, and there wasn't a lot of battery left. They were really poorly located. So you can see the work that Quentin did to move those batteries back to the firewall. The other thing that's pretty noticeable here in this first moment is the header tank that Quentin had installed, which is a standard thing they do at Turbine Power Technologies that was invented, my understanding is, by Quentin's dad, John. And what it basically is it's a can, it appears to be steel, mounted vertically, and then at the very top of it is a level indicator light. So what happens is, in the event that you drain a tank, you have that much gas to go before the engine's going to flame out. And the way in the cockpit is when that first, it's about 2 inches down from the top of the can, when that fuel comes down to that 2-inch level, a light comes on the cockpit, and you have, it's on the order of 30 seconds to switch tanks or turn the boost pump on or whatever you're going to do to try to keep the engine from flaming out. After looking around inside the cowling, then I started just going through sort of standard cockpit stuff, working through my checklist. Here you can see me checking the trims, making sure that the trims fire the right direction. It's not uncommon for when the airplane gets taken apart or put back together for left roll trim to become right roll trim, etc. So it's just something that we check. Now I'm starting to work my way around looking at the flight controls. So here I'm removing there's an access door there underneath the elevator to look at the bell crank for the elevator. So also through that access door you can see the down locks for the tail wheel, and then all the associated mechanisms. So the tail wheel, when it retracts, there's gas struts that push the over centers in place. So those gas struts push the over centers in place. The hydraulic actuator pulls against those, and then the tail wheel comes up. When it comes up, it hits a pad, and that pad retracts the tail wheel doors. More on that later. But now here you can see I'm inspecting all that. On the opposite side of the tail wheel is another access door, which gives better viewing of the lock itself and then all the associated up and down locks. Again, this becomes more important later. Here we can see looking at the brakes, but standard stuff, looking at the wear on the pads, looking at the condition of the rotors, and in this case the brakes are really critical because the airplane has so much thrust at idle, so you end up spending a lot of time thinking about the brakes. Here we are up in the gear bay, looking at the inner gear door locks. So this was a major sensitive spot on the program back in 2016. There were several times where I was getting ready to dive the airplane to do the high-speed envelope expansion as part of the phase 1 flight test, and I would just start to lean the airplane over, and I would get an inner gear door light in the cockpit, which showed that the inner gear doors had come off the up stops. And what it basically comes down to is there's a latch that's tied to the gear retraction extension handle in the cockpit, and there's not a lot of spring power to pull that cable back. So there's a little spring down at the latch, and there's not a lot of spring power to pull that bit of cable from the gear handle in the cockpit down to the latch to allow the latches to extend, allow the gear to lock up. Again, more on that later, but it's a sensitive spot for this Thunder Mustang. My understanding is there are some mods for it, but this airplane doesn't have them. Here you can see I'm pulling off the access doors for the aileron bell cranks. Again, this is like standard annual stuff. It's not really associated with the specific work that's been done on the airplane recently, but this airplane's been sitting, right? And yeah, it had a condition inspection, but we're getting ready to fly it across the country. It's an easy thing to look at. Looking for slop in the controls, looking for making sure the right kind of hardware is installed, etc. Here we go, back up underneath the cowling. The big thing here is idle stop and then the beta mechanisms, which we'll get to in a second. Then some cockpit cleanup stuff as I get ready to try the airplane on and make sure that all my stuff fits in the airplane and the comm cords, etc. The Thunder Mustang has surprisingly a lot of baggage. Well, let me rephrase that. This Thunder Mustang has surprisingly a lot of baggage. I wouldn't be surprised if that baggage is limited when you have the radiator installed in the back. Obviously, this airplane doesn't have that. Here you can see I'm taking out all the seat cushions and getting the seat belts straight. Having a nice sterile cockpit is good for good flight test. So on this side of the cowling is the hydraulic pump. There's, again, more on this later, but the hydraulic pump in this airplane, my understanding is it's not stock. This is not the standard Thunder Mustang configuration. The pump is sort of an oddball pump. It's an inexpensive pump, but has been a problem on the program. So here, while I'm looking the airplane over, it's a chance to get reacquainted with the compromises that are the hydraulic pump. Checking fuel levels. And there was more, but like I said, it's typically 3 to 4 hours to do that inspection. So there's a weak point on the Walter 601 engine. Again, I am no Walter expert. Talk to Quentin, but the way it was explained to me is that there can be air in the fuel controller in the cockpit, and a lot of times what happens is about the time you stand the power up, release the brakes, you're heading down range, get airborne, suck the gear up, and about that time it flames out. And that has to do with air in the fuel controller. So the test associated with that is get the engine running and turn the fuel pump on and look for a change in engine RPM. So we needed to do that test. I personally am consistently concerned about the relationship between brake power and beta in this airplane. The throttle geometry is not very good because of the narrow cockpit. The throttle quadrant has to be really narrow, and as a result, there's some compromises there. So it's really critical that you get the beta set up right. We'll get into it more in a second, but fundamentally speaking, in order to get more beta power, zero thrust or negative thrust, you have to make the engine more likely to PIO when you're powering up to take off. And the less beta that you have, the more demand that puts on the brakes, which obviously getting stopped at the end of the landing is key, but also just steering, it becomes an issue because the engine can make so much thrust at idle. So this test was about checking those two things. Here we did a quick walk around and then jump in the cockpit. Again, I had never been formally trained by these are the experts on the Walter engine. So I tried to take every moment that I could to check that all my procedures were good. I had what I remembered from the long nose. I had the checklist that I had developed for the long nose. I had the checklist that the owner had developed, and now I'm in the presence of these folks at Turbine Power Technologies who are all, well, they certainly have more time running the engines than I do. So I'm showing 24 volts.
That's good. Now, if it drops, when you go to start, you want to watch that as well. If it drops below 20 to about 18, and
so I'm
anything
seeing
lower
20
than that,
here on the checklist, so that's reasonable.
Yeah, if it drops below 20, you know you need to recharge your batteries.
So that's DJ on the left wing of the airplane. He is the high time guy that works for Quentin, and he's walking, I'm trying to ask intentionally stupid questions to try to trigger him to say things that might give me more insight into what's going on with the airplane. So I apologize if it appears really simple, the questions I'm asking, but it ended up being really useful. And that's going to be the same aboard that we talked about, which is just going to be master off.
Yeah, you can just pull the condition lever off, turn the fuel pumps. That's not going to be that's not an engine issue, so it's not as urgent.
So, sorry, the reason I keep bringing that up is when I played this game before with this airplane, this is a momentary switch. You put the switch in the up position and it was like you could release the momentary and the start sequence would not stop.
Okay, so this has the TSLM timed start sequence.
Okay.
So that should usually run about 20 seconds on its own.
And so that was just concerning to me, as a guy responsible for not burning the engine. I'd be like, well, how do I stop it when I need to stop it?
Well, you're right.
So it's fuel cut off the master.
Yeah, maintain on that EHT, keep your hand on the condition lever. That way, if anything goes wrong, you can just abort the fuel all by itself and you'll be fine.
All right. So the start process for the Walter starts with condition lever to the on position when you're effectively just turning the fuel cock on, and then you start the start sequence. This has an automatic start feature which runs a timer and an automatic ramp up of fuel with the ignition sequence, and then it has a manual bypass where there's a momentary switch on the panel. So basically you let the sequence start and then you watch the engine temperature, and in the event that it looks like it's going to exceed a limit, you have a momentary switch in the cockpit that you can cut off fuel and let the engine cool down. So here you can see me doing that. once you get it started, it's a twin spool motor. So the primary spool, the internal spool, the hot spool is running, but the propeller is not. So it's the propeller is spinning, but just only barely. The blades on the propeller are feathered, and it's just sitting there sort of freewheeling at a real low RPM. So then the last step is, once you get the generator on, is you pull the prop or push the prop from the feather stop to the fine pitch stop. The blades go fine. There's less drag, which allows the engine to accelerate, and then that allows that secondary spool to come up to speed.
Okay, you put your prop forward.
You can see once the propeller starts spinning, that's when the wind associated with all that idle thrust, which like I said is an issue on this airplane, starts blowing by. You can see DJ sort of being blown back. You can hear the wind noise around the camera and all that goes with it. So the check for the air in the system is, like I said, it's a fuel pump off and then check RPM. So you can see doing that. And then I put the engine in full beta, and pull it all the way back into full reverse to see how the beta is functioning. And it wasn't looking good. It wasn't looking like we were going to have an easy day on the beta front. After the beta check and the fuel pressure check, we shut the engine down. Quentin showed up.
This is what I need to talk to him about, because your beta light shouldn't be on unless you're in beta. So
that's the start timer, is what that's talking about, right?
That I'm not sure.
And again, I'm just trying to ask him every dumb question I can think of in the hopes that it may trigger him to say something else that ends up being useful.
So and obviously, if there's I'm not taking off with a chip detect light on.
No, those lights also shouldn't be on. That means we need to check our chip detectors or the connectors themselves.
It looks to me like it's a lamp test situation, like that switch
I think it is.
It's like stuck on, because it's very weird that everything is.
Yeah, because you see the low fuel's got its own and that one's not on. Try cycle the power off and back on.
Oh, here's an important thing. This is a mistake that I made, and again shows just trying to come back up to speed with the airplane. There is a hydraulic accumulator. If the hydraulic accumulator is charged up, it doesn't matter whether the pump is on or off, and therefore there's hydraulic power available. And what happens is if you turn the master switch off, it automatically takes the inner gear doors and signals them to the open position with power. So they go and they go down, right? And then if you turn the master back on, and they go close.
Try cycle the power off and back on and see.
They stick down a lot and forward enough that you can see Jose out in the front of the airplane is very close to those doors, which I'm not proud of the fact that I wasn't aware enough of the fact that when I was going to turn that master switch, the doors were going to move, and Jose was standing in such a place that he could have been at risk. What I should have done is said power coming on, clear the gear doors or something to give him a heads up. I was still getting used to operating the airplane again.
I would say the start went well. What
yeah,
I do
the start was very nice. No, I mean, if anything, you were kind of pushing the EHT
more
too much, but that's just being safe. So I mean, you didn't hurt it at all, really.
I'd rather that than the alternative.
Yeah.
Well, if you go too much, you can also hurt it. You'll get it out of the momentum on acceleration, and then it's going to want to hang at like 45%. So that's why you got to do it enough initially just to kind of keep the temp down, but then you kind of got to let it ramp up a little bit.
Okay. It's good news, or good to understand that.
So you can hear us talking about it there, but just to be totally clear about what's going on, there's a series of eyebrow lights across the top of the panel. It has, and I'm just going off memory, which of course is dangerous, but it has 2 chip lights, it has a hydraulic pump light, it has a fuel pump light, a start light. The most important information closest to your line of sight, and the assumption that your head's up flying. And for the entire time that we were doing the engine run, all the lights were on, which I wouldn't have expected. So coming out of that engine run, the question was, what's going on with the system and how can we fix it? The assumption was that it was stuck in the test mode. So we've all flown airplanes, so I don't need to tell you, but I'll tell you anyway. Anytime you have an indicator light, if the light bulb fails, you would not have any indication whether the system had failed. So there's typically a test lamp light or switch, and you hit the switch and it lights all the light bulbs so that you can be confident the light bulbs function before you start on your flight. Based on what we were seeing, the system was stuck in that test mode. So maybe the switch is bad, maybe the circuit's bad, I don't know, but it gave me something to look at.
Okay. Hey, Jose, you want to push real quick?
And then the lovely service of Turbine Power, they pushed me back in the hangar. Thanks, guys. I feel like somebody special now. VIP. That's right. Good living. So we pushed the airplane back in the hangar and I went to work. Pulled the access door. There's an access door right behind the panel between the glare shield and the cowling. I get in there and you can sort of see the wiring and stuff. The problem is that all the wires were soldered in place. There were no connectors associated with the test lamp feature. So I had to go get a soldering iron. So I went and picked up this soldering iron from Lowe's. Break the leads. And then we could check for the functionality of the switch. Once I checked that the switch was functioning as it was supposed to, then we knew there was a short circuit in the system, and I started cutting into the wiring system. It became clear pretty quickly that the number one, it was going to be hard to fix the eyebrow lights to function as I thought they should, which is that they should all be off except for the light that was having a problem. What we ended up figuring out was that the lights functioned as they would be expected to function as long as their hydraulic system was functioning properly. So in the event that the hydraulic system was below the set pressure and the pump was therefore signaled on, all the lights would be on. So something to do with the low pressure switch is sending power backwards through the test lamp circuit. So we decided that that was an acceptable way to operate the airplane, that being if you had a hydraulic failure, you'd be quick to land anyway, so the chip lights, etc., you're not going to land any faster than you can anyway. So we were comfortable proceeding towards a test flight in that condition, and that's where we left it. So getting ready to go up and do the first functional check flight of the day. I climbed into the airplane, got everything situated, and before I started the engine, I checked to make sure that the radio was functioning. And in doing so, determined that the radio was not. So it's an old problem with this airplane, which is interesting because it followed. There's new radios in the airplane now, but it still has the same issue, which is that even with the volume for the radio turned all the way up, the volume in the headset's very low. Part of it is that it's a loud airplane, yes. Part of it is that maybe there's some static in the radio, but there's also just like a general volume thing going on. So in order to fix that, we aborted the flight and I went back and fixed my helmet. Just a quick overview. In order to get audio comm so that I can record what happened from an audio standpoint during the flight, I have cords that connect in between my speakers and the airplane to give audio to the cameras. So that takes a little bit of impedance. Then I run earbuds, which take a little bit of impedance, and then I run the 2 speakers in the headset. So the idea is that in the event that you have a earbud failure, which is actually pretty common, you can unplug your earbuds and then the speakers in the helmet will work. You'll have something. It's not great, but you'll have something. What I did to fix the radio was I just disabled one of the earphones. So it's a dramatic, the earphones by far are the biggest impedance draw on the system. So by getting rid of one of the earphones, you dramatically change the amount of overall impedance for the system and dramatically raise the volume of the radio. And that was my fix. And I know this because I know this fix because we dealt with all this back in 2016. So here's my second attempt at a functional check flight.
A long way from home.
Check, check, check.
679, copy 111, 248.
So of all the things I did that day, this is the moment that I think I'm the most embarrassed about. Just an overview of what's going on. Talked about the balance between beta and brake being absolutely critical on this airplane. I'm coming out of the chocks, and you can see it on my face. I roll the airplane, undo the beta lock, draw the throttle all the way back to full reverse, and there's still too much residual thrust. I don't have enough brake power to steer, let alone brake. And you can see multiple attempts where I'm trying to let the airplane accelerate to sort of a natural speed with full beta. So with full reverse, the airplane was still going to roll 20 miles an hour or so, and then doing max effort brakes to see how much, what would an emergency stop look like. And it was not acceptable.
So that's traffic file 445, Echo Romeo, departing at runway 23, bad traffic.
So that's going on. Number two is my radio is still not acceptable. So I'm hearing 10%. It's misleading in the video because the GoPro did a better job of getting the radio noise than the headset was doing. It sounds like the calls were a lot clearer than they were.
Deland FL, Seneca 61 Foxtrot Hotel, final runway 23.
But I'm not hearing all that's going on. And this airport is slammed with Embry-Riddle traffic. I've never seen anything like it. It was like 3 or 4 waves a day. You'd go from the airport being totally quiet like you'd expect for a little GA airport to like 7, 10. Embry-Riddle airplanes stacked up with students working on takeoffs and landings. These are Cessna 172s that are flying around the pattern at 80 knots, and to be perfectly honest, anything less than 150 in the Thunder, and I'm heads up at least. Anyway, so.
Adam clear. Current traffic 545 Romeo is on a left base, thank you for approach mid-23 Deland. Deland traffic, Seneca 61 Foxtrot Hotel, clear runway 23 on Charlie.
So I'm getting ready to taxi out into this environment with unsatisfactory comms, brakes that I'm not happy with, and you look at how long it took for me to make that decision, and that's embarrassing.
Traffic file 445 Echo Romeo, left crosswind for runway 23 left. Traffic file 445 Romeo, down front of 23 left.
Again, I'm being overly critical, and because sort of the way that we do business, I have to be.
Traffic file 445 Echo Romeo. Charlie runway 23, we're going to taxi Alpha.
I knew within a couple seconds of coming out of the chocks that this flight should not proceed, and I ran the engine for a good 10 minutes trying to convince myself that there was some way I could move forward and get the flight done, make the customer happy, move the project down the line, etc. It's that standard success thing that we all, that pilots in general struggle with, and here you can see I'm struggling with it. So finally, I did abort, taxied back, shut the airplane down. And and Quentin went to work.
Problem?
I'm probably getting about half the radio calls. This airport's too busy. The brakes are so much worse than I remember them. I'm sure it's just compounded by the beta having something about.
I was pretty clear about the beta issue, and there was some stuff that he could do. Again, he's playing with that balancing beam where if he gives me more beta power, more reverse thrust, then the throttle becomes more sensitive, and there's more likely to be a PIO during that initial power addition for takeoff. But you know, I made it clear I wasn't going to fly the airplane how it was, and so he had a directive that allowed him to go work. Then I went and called the owner and talked to him about the radio situation to see if he had any insight on that. So every time Quentin would make a beta adjustment, we needed to run the engine. So he'd make the adjustment, we'd run the engine, I'd start the engine up, put it in full reverse, check to see how much brake power was left, shut the engine down, he'd make another adjustment, and we went through that 3 or 4 times. So while we're doing that, the upper cowl's off and they're working on the linkages, and Quentin's on one side and Heath is on the other, and DJ, and they're all in there, and they're noticing that every time we start the engine, there's more and more oil puddling in the lower cowling. And kudos to Quentin. They called it, and they said that they were uncomfortable flying the airplane that day. They wanted to, by this time it was getting late in the day, the guys were ready to go home. So they said, we're going to come in first thing and make sure that the oil lines in the bottom of the engine are correct. And so that was our plan at the end of day 1.
Sounds like we had a productive day.
Yeah.